Hello and welcome back to Zig's Math Lessons. I am your host, Ziggleby B. Stunk. Welcome back. This is where we become the best darn science, technology, engineering, and mathematics students for miles around. Let's continue with Pascal's triangle. This is it. 1, 1, 1. Take a look at this. Where are these numbers coming from? All of these are ones. All of these are ones. 1, 1, 1. Where did this 2 come from? 1 plus 1. Where did this 3 come from? 1 plus 2. So what is this question mark? It'll be 3 plus 3. 6. And how about this 3? How about what goes here? 3 plus 1, 4. And on the end of 1. On the end of 1. 1 plus 4. And so on. 4 plus 6. And so on. This is known as Pascal's triangle. Notice, here we go again. 35 is 15 plus 20. 21 is 15 plus 6. 7 is 6 plus 1. This is where the numbers come from. It's known as Pascal's triangle. Let's make some observations. First of all, the natural numbers are along this row right here. It goes 1, 2, 3, 4, 5, 6, 7, 8, and so on. Another observation is adjacent numbers in this diagonal add up to perfect squares. 1 plus 3 is 4, and that's 2 squared. 3 plus 6 is 9, and that's 3 squared. 15 plus 21 is 36, and that's 6 squared. Pick any two numbers in this diagonal that are beside each other, and they add up to a perfect square. 15 plus 10 is 25, and that's 5 squared. Another observation, the rows are symmetric. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. The rows are symmetric. We've got the natural numbers present. There are many patterns of numbers buried within that triangle. Notation. The rows and the terms are numbered, starting with 0 and counting 0, 1, 2, 3. So in other words, this is the 0th row. This is the first row. This is the second row. This is the third row. So the rows are numbered starting with the 0th, then the first, then the second, then the third. This is the 0th term, the first term, the second term, the third term, the fourth term. 0th, first, second, third, fourth. And by the way, let's also observe, since this is the 0th, this is the first row, the second row, the third row. This term here tells you which row it is. This is the third row, and it's got a 3 right here. This is going to be the 6th row because it's got a 6 right here. Getting to know Pascal's triangle. The rows and the terms are numbered, starting with 0 and counting 0, 1, 2, 3. Each term has a subscript denoting row and term number in that order. So T sub 6, 4 means 6th row, 4th term. And T sub 6, 4 apparently equals 15. Let's check. 6th row, 4th term. 0th, 1st, 2nd, 3rd, 4th, 5th. 6th row, 4th term. 1st, 2nd, 3rd, 4th term is 15. T sub 6, 4 is 15. T sub 8, 5 means 8th row, 5th term. Let's check. 8th row, 5th term. Let's go back and check. 8th row is this one because it's got an 8 here. And 5th term, 0th, 1st, 2nd, 3rd, 4th, 5th. So T sub 8, 5 is this right here, 56. T sub 8, 5 is 56. Now T sub NR means the term that's in the nth row, the rth term. But there's another notation for it. It could be NCR. In other courses, T sub NR is called NCR. In fact, there's a button on your calculator. So pause the video, find your calculator, and find the NCR button. In Texas Instruments, it'll be hidden under PRB. Usually it's over the 2 or over the division sign. Look for your NCR button and learn to use it. All the calculators are different. 6C4 should be 15 on your calculator. 8C5, which is this, T sub 8.5 is the same as 8C5, T sub 8.5, should be 56 on your calculator. And here's a question. What is the 12th term of the 15th row? Well, this will be 15C12 because the row comes first. So 15C12 on a calculator should get you this, 455. If you don't get 455, well, then you need to find out how to use your calculator because 15C12 is 55. Let's also note, go back and make an observation here. In the 8th row, there is 1, 2, 3, 4, 5, 6, 7, 8 terms, if we count this as the 0th. So it would make no sense to ask for, say, the 10th term in the 8th row. That would make no sense because the 8th row only has the 8th term. So when we're doing this little exercise, it would make no sense to say, what is the 20th term in the 15th row? Like to go 15C20. We'd be asking for the 20th term in the 15th row. That would make no sense. On a calculator, if you went 15C20, you'd get domain error. But 15C12 should be 455. The triangle could be represented by this. T sub 0, 0, 0th row, 0th term. T sub 1, 0, 1st row, 0th term. 1st row, 1st term. 2nd row, 0th term. 2nd row, 1st term. 2nd row, 2nd term. 3rd row, 0th term. 3rd row, 1st term. 3rd row, 2nd term. 3rd row, 3rd term. See how the last number is always no bigger than the first number? 4th row, 0th term. 4th row, 1st. 4th row, 2nd. 4th row, 3rd. 4th row, 4th term. Let's take a look at this. Here I've written out the triangle. Row number, sum of terms. So in the 0th row, this is the 0th row. Add up all the terms. Well, it's just 1. In the 1st row, add up the terms. 1 plus 1, 2. In the 2nd row, let's go to the 2nd row, add up the terms. 2 plus 1 plus 1, that's 4. In the 3rd row, add up all the terms. 8. In the 4th row, add up all the terms. 16. 5th row, add up all the terms. 32. 6th row, add up all the terms. 64. 7th row, add up all the terms. 128. And 8th row, actually take a calculator, add up all these numbers. And you'll see that they add up to 256. So we conclude, we notice that these are the powers of 2. The sum of the terms, 1, 2, 4, 8, 16, 32, are the powers of 2. So we can suspect here that it's got something to do with the row number. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8, and so on. In fact, we can conclude that the sum of the terms in a given row is 2 to the n. So the sum of the terms in the nth row is 2 to the n. Now comes a challenge. Expressed as a single term from the triangle. T sub 9, 5 plus T sub 9, 6. Well, I didn't write out the ninth row here. But this is asking for the ninth row, fifth term plus ninth row, sixth term. Before we figure out how to do this without seeing the numbers, let's see if maybe we can establish relationships within this triangle. Take a look at these three numbers in the triangle. This one, and this one. 20 plus 15 is 35 because that's how the numbers are generated. But we could say 35 take away 15 is 20, and we could say 35 take away 20 is 15. So there's a relationship amongst these. I like to liken it to generations of people. For example, here, each row is a generation, and the next row is the next generation, and the next row is the next generation. And what happens is we get these family relationships where there's two parents and a child in the next generation. Or if you prefer, two terms beside each other, and their sum is in the next row. So if we could think of it that way, when we saw T sub 9, 5 plus T sub 9, 6, we know that the answer is going to be in the 10th row because the generation of this row is the 9th generation. So it will be T sub 10 something, but T sub 10 what? Well, if we observe a family of numbers, this is the first term, second term, third term. 15 is the fourth term in its row, and 35 is the 1, 2, 3, fourth term in its row. So 15 and 35 share a term number. They're both the fourth term. So T sub 9, 5 plus T sub 9, 6, their offspring, their child, the result of their adding will be in the 10th row, and it will share the higher of those two term numbers. The higher of 5 and 6, of course, is 6. So the answer will be T sub 10, 6. Let's try another one. T sub 14 minus T sub 14, 10 minus T sub 13, 10. So this is subtracting. We notice here that 35 minus 15 is 20, and 35 minus 20 is 15. So when you subtract this way, you get 20, and when you subtract this way, you get 15. And here we're doing some subtracting. From the 14th row, subtracting something in the 13th row. And we notice we're subtracting something that has the same term number. So we would expect to get, so in other words, we are subtracting this way. We're subtracting this way because this is the 1, 2, 3, 4th term. This is the 1, 2, 3, 4th term. We're subtracting the two that match. We'll get the one on the left. So this will be T sub 13, 9. And let's try another one. T sub 43, 31 minus T sub 42, 30. Observe what we're doing. We're subtracting something from the previous row. This is row 43, and this is row 42. So we're subtracting something from the previous row that has one less term number. 31, term 31, and we're subtracting term 30. So in other words, we're subtracting in this direction, to the left, if you wish. up and to the left. And the result will be up and to the right. But when we go to the right, they share the same term number. So this will be, the result of this subtraction will be t sub 42, 31. That's a fairly difficult concept to grasp. Maybe listen back and dwell on why those three statements, A, B, and C, are true. I really do hope that you can figure that out. It's a bit of a puzzle, and good luck with it. I'm Ziggleby at Biestum. Thanks for watching. I hope you enjoyed it. If you liked it, leave a like. If you like the content, then please subscribe. Check back later for updates and new videos, and I'll see you soon.